Hola, ya estamos en vivo después de la pausa de comida. Muchas gracias por acompañarnos. Y en la primera sesión, acabo de recordar que esta sesión es en inglés. Entonces cambiamos. Welcome to the first session after our lunch break. Thank you very much for joining us. And our next speaker is María José Molina-Contreras. She's a passionate biologist and now working as a data scientist, and she's very focused on beginner-friendly projects. She will talk more about herself, her work, and yep, the floor is yours, Maria.
Thank you so much. Well, today we're going to talk about how to create an indoor air quality monitoring and predictive system. But before to start with that, let me introduce me a bit. As Katia mentioned, my name is Maria Jose. I am a plant molecular biologist by former, and I am working as a data scientist in Germany. But in my free time, I enjoy doing yourself projects with microcontrollers and IoT, and kind of mixing all my projects or all my interest areas or things that I want to learn. And also at the same time, I like to kind of help to my friends or improve my home, depends of the project. And this is one of those examples. And what was the motivation of this project? Well, when the pandemic situation started, I changed my lifestyle, as probably most of us. Um, Before, I was having a really active life, going to the office, doing sport, joining people, and then I had to be at home, working from home. And at some point, I start to feel a lot of headache. I don't know, some kind of feeling sleepy the whole time. And analyzing the situation, I start to think, what could be the reason? And at the beginning, I thought, well, maybe it's because I am always with working with the computer, with the artificial light. Maybe it's the stress, and also the situation. Kind of a lot of excuses until one day I start to feel that I needed kind of open more my window. And was then when I realized that every time that I was in starting to feel kind of sleepy, if I open the window, I kind of feel better. And then I thought, there is something in the air quality of my apartment that is probably it's affecting to me. And this was how this story started. Then the first thing that I did it was do research about the different factors that could be contributing to this indoor air quality. And I found that there was a lot of possible things that are playing a role in on that. For instance, the number of occupants. Of course, if we are five people at home with cats and one dog, it's different that if you live alone, for example. Also, there are other factors like humidity and moisture. If you have a really high humidity and moisture, this could produce or help to grow some fungus, for instance, or things that could produce also this air quality, affecting this air quality. The ventilation design. This is one of the things that I realized, as I mentioned before, is how often and how do you open your windows? Because at the beginning, I never thought about how open my windows. I just was at home, open one window, wait some minutes or some time, yeah, and then close it, and that was all. But when I start to feel these symptoms, I start to think that maybe if I had different opening combinations, this could have an impact. And I can tell you that yes, this has an important role. But maybe we can mention about talk more about that later on. Also, there are other factors like pollutant sources, right? It's not the same if we live in a city full of cars, or we live in a close to a factory, or if we live in a countryside or in a small town when the pollutants are probably lower than the other conditions. Uh, Moreover, we have also the situation of gases. Are in case that if you live close to volcanoes, for instance, the chance to have more gases at home will be higher than if you don't live in this situation, right? Then, after all this huge wall, it was like, okay, but what is my case, right? Because um, I have a lot of things to check what it's my case. And as I am scientist and also I am data scientist, I always go to the bibliography and I like to see what scientists have to say about the topic. And I realized that there was a lot of publications talking about CO2 specifically. And then I decided to just take a look to this option. In this case, we have in here three publications, three titles of publication. Of course, there are there are other options and more publications. Just is a sample that what I did, my research, what I did, and one of a very interesting one is the first one, because they were doing research about how the CO2 concentration could have an impact in human decision making performance. And I thought, oh, maybe we are in that direction, because I was having this feeling that. And then I say, well, let's check the CO2. What brings me also to the point that say, hey, wait, if CO2 levels has an impact in making decisions, if you need to negotiate maybe your salary with your manager, be sure to open the windows first before to have this conversation, or before to have some important conversation. Maybe it's a good idea, open the windows and then have this conversation. But out of jokes, let's continue on about more serious topics. Yeah, in here we have the different values, because of course we need to know what is considered good, what is considered bad, or in terms of CO2 concentration, right? And of course, this is important to understand that depends of the source. The numbers is more approximated. It's a kind of ranges more than a specific number. But of course, for this project, I at some point I had to create also this range and consider good or bad at some point, just to let you know. And also, of course, these feelings or these symptoms could appear before or with lower or higher concentrations, depends of the person, and also depends if because humans we have different level of sensitivity, and also we can have other previous health things. Just take in consideration that this is an indicative plot and numbers. But what is quite in consensus is lower to 1000, as we can see here. This is considered as a good. We can consider that our home place, our indoor is okay, is in a good conditions. Higher to 1000, or a bit around 1000, they say in that way, we start to consider that our air quality it's not super good. And it's in here when you can start to feel sleepy. That it's something that, as I mentioned before, is something that I was experimenting. When we are around 2000, we have more serious symptoms like drowsiness, headaches, loss of attention, nausea, or others. But as I mentioned, this could happen even with lower values. Depends, right? And then we have very critical situations once we go higher to 5,000. These, these are some of the symptoms and values. As I mentioned, we can have more. But this motivated me a lot to build this project and say, okay, well, let's have control of the situation and let's see. Then this is very simplified. You're gonna see that from to step, we're gonna go from really basic project structure to more complex. We are gonna add different components and different uh, elements that will bring us the whole story. But for now, let's start really simple. I had some sensors where I was collecting data, and with this data, my main goal was, for one side, monitor those values because I want to have control of what is going on, but also I wanted to predict when this situation will be bad for my health and when I could avoid the situation, because the monitoring system is really nice, but it's reactive, right? You would have the situation and then you react. With the predictive one, you can avoid to arrive to this situation. You can just see when or what will be the value in the next 1 hour, 2 days, whatever it is, your prediction, and then decide what to do to prevent this situation. For that reason, I combine the two components. Let's start from the beginning. Let's start with the sensors. On the left, we have an air pollutant sensor. In this case, this sensor could help us is what we are taking is the particle size. We are taking different types of particles that it have different concentration, as you can see, like 1 PM1, PM2.5, and 10. This means how big it is, those particles. And then on the right side, we have the CO2 sensor. This is specific for CO2. In this case, it could be other things. Then my first idea, of course, this is a word, proof of concept, try, see what was working. You know, it's a kind of proof of concept that I needed to try, learn, fail, try again. And this is part of what I'm gonna also share with you. You're not gonna see a final product from the beginning. You're gonna see how was kind of the process, the development process. And here we have the particle sensors that I mentioned before. On the bottom, we have a battery. And also on the right side, we have a Qt Pi microcontroller. This microcontroller is really, really small and has this advantage that you can kind of create small things, and it's really nice because if you are want to wear this thing or this sensor or this product or whatever you want to build, it's really useful. Also, I was developing that with using Circuit Python, that if you are not familiar with, is a fork of MicroPython, that it's a version of simplified Python for microcontrollers. And the challenge that I had with this system is that was working well, I was okay. But as I mentioned before, I wanted to collect the data because I wanted to build the predictive system. And with this system was a bit challenging because this microcontroller had not a space to collect the data, or had not Wi-Fi or the wireless, sorry, or Bluetooth. For that reason, I thought, well, it's really okay, it's really nice, but I want something else. Then I thought, okay, let's test the sensor for CO2 using another approach. In this case, I was using this. In the middle, we have the microcontroller that is a ESP32. This case has a wireless, and in this case, I was using MicroPython, and was working also really good. The challenge in this system is that when this was working and I was kind of happy, I thought, yes, but now I want to have more complexity in the system. I want also to combine the particle sensor, and also I want to have a big screen with I can send notifications. I I start with really simple thing, but then I wanted to have something more complex. For that reason, I moved to another system that where I include a Raspberry Pi with including wireless, the zero, and I connect both sensors. Here we have the particles, the CO2. This is the Raspberry Pi, just cables. As I mentioned, I create this idea of more complexity, and then I wanted to have this notification system with an interactive screen. That this is what I need, what I decide to use. It's a Raspberry Pi 4, and in this case, and also this Raspberry Pi Zero that was connected with the sensors. If someone is wondering why this Raspberry Pi 4, do we need this? Do we need another thing? Honestly, I use it. I use the Raspberry Pi 4 because I got it from one workshop from Pi Ladies where I participate, and I love to use the things that I get from the community, and I'm super grateful for that. And that was one of the reasons why I used this specific Raspberry Pi 4. For sure, other options are also possible and good. Then let's go back to the project structure, because I am giving you a lot of information, sensors, things, Raspberry Pi here, another Raspberry Pi there. How it looks like, right? And here we have the two sensors that I show you, the particles and the CO2. I was collecting the data in this Raspberry Pi Zero, and then with a socket connection, I send this information to the second Raspberry Pi, where was the screen, to have this monitoring system where I could check what was going on. You no worries if you are getting lost or it's not super clear. You are gonna see a bit later more in detail, and you're gonna see in real life. But if we go to this point, if we go to this point of the data analysis, I also wanted to share with you what kind of data, right? Because what you do, what can you do with this data? What is interesting? What you can check? In this case, we have in the x-axis, we have dates, and the y-axis, we have the different parameters. We have the CO2 in the first plot, the humidity in the second, and the temperatures in Celsius degrees for temperature on the bottom. And maybe you can see some kind of oscillations that we are going to talk a bit later. But there are some very interesting things that maybe if you are familiar with work with sensor data, maybe you can start figuring out. If not, also we are going to be later. But as you remember that I told you before, around 1,000 1,000 as a CO2 part per million was okay, but up to that, after that, it was bad, right? And we can see some peaks on here that are really high. Let's talk a bit of that. In here, we have another plot. On the x-axis, we have this CO2 part per million. And on the y-axis, we have the frequencies. How often I had this situation at home. In green, also is here with a happy face. I'm indicating when the values are good, that my air quality was in good conditions. Then in yellow, we have also this phase where it's meh phase, but this could be better. And then we have a very sad phase, and here in purple, where the values are not good at all. The arrow, if you can see, if, it's indicated the most extreme cases. But if you remember what I was talking about, that after this 1,000, it's not okay. Close to 2,000 is a problem. I was having really high values at some specific days at home. What is worried what worried to me, because I didn't realize until I saw the data, and I saw that the symptoms that I was kind of having maybe could be related to that. Of course, I cannot correlate directly that, because of course it's more complex, maybe other things as I mentioned before. But what is for sure, this had an influence in my health and in my life. For that reason, these kind of projects can help us to have a better life. And for that reason, I motivate to you also to kind of implement or check your data. Then this is for the monitoring part that later on we are also take a look, but also let's take a look to this predictive part, or part of the project. In this case, what we are going to do is a predictive system using machine learning, and then decide when we are going to need to activate our ventilation system or just open our windows. Well, if you're not familiar with this kind of data, of this time series analysis, what we have is, in a certain time, we have a collection of data from sensors, and then we evaluate and we do predictions based on time. For instance, in here is just an example, completely different topic, but I just wanted to show you how in this plot, during the time I was collecting data for something completely different sensors. Don't just don't think on that right now. And then at some point, something happened and change. And as you can see, the behavior is quite different. This is the kind of things that we want to analyze and predict, because uh, I want to know if this when this is going to happen, when this event could happen, and also later on or before this happened, how works the system. And here we have some real data from those sensors. Okay, don't be worried, because this plot is could be a bit overwhelming. There are a lot of things, a lot of data, but let's go step by step. And the x-axis, we have the index. The index is the date, but what we are doing in this kind of approach of time series is use the date as an index. We are not we don't want to know if it's the day 5, the 10, or whatever. In that case, we want to simplify this using an index. And of course, then you can know which day was the index 5 or whatever it is. But to simplify that, we can use this index approach. Then in the x-axis, we have the CO2 levels again. And of course, we have really interesting things that I will, if this was in life, I will ask you about those behaviors. For instance, for this arrow or this square, this rectangle. Sorry, but as we are in online version, I'm gonna just do it by myself. But yeah, yes, but I'm gonna give you a couple of seconds in case that you want to think what could happen. Let's start with this arrow, this moment. In this case, if you take a look, I was having some values around quite high if you take a look to these peaks. But at some point, that it was more than 1,000. But at some point, something happened and went really low, close to 400. Can you think, or do you think that you know? Can you know what happened in that time? I'm gonna give you a couple of seconds to create your own hypothesis. Well, what happened in here is that I was not at home. I went on holidays. And this means that I was, of course, collecting still data. And what happens is that when you are not at home, you are directly affecting to the system. Then we have a second arrow indicating here that we have a decrease of the CO2. But if you take a look, it's not the same as the previous one, because the previous one was around 400, but this one is close to 700, 800. Do you know what could happen in here? Um, could be more than one things, honestly. But in this case, what happened is that I changed the method of how I was opening my windows. I start to play with the kind of way that I can create these air distributions at home, and check what happened if you open only one window, what happened if you open two, what happened if you open the extremes and or not, and this kind of behavior. And at some point, this star in here, and that is not in the arrow, as you can see that it is starting to decrease. But then this combination was the best one. If you're wondering why, then we I I come back to higher levels, is because sometimes I forget I forgot to create this combination again. It was just like, okay, I need to open the windows, yes, but I have a meeting. It's really cold because it's winter in Germany. Yeah, that was what happened in this case. And that also in here in the rectangle, we have a really high peaks, right? As you can see. And what happened in there is that I was having more humans at home. Then what is important to have in consideration, if you have visits or you have more humans at home, open more often or more time or better combination in ventilation, because this is affecting to the air quality at your home, and this is also affecting to you. There is other thing to end with, that is this decreasing this this tendency of the accumulation. Also, I would love to ask you, but as we are in remote, I'm gonna just give you the answer: is that the winter was starting to over and start the spring. And this has a really important impact in the system. First, because I could keep the window open for more often, more time, but not only that, also is how is the temperature affecting to the CO2 accumulation and those. Saying all that, how about the predictive system, right? Because there are a lot of ways and there are a lot of methods and a lot of strategies that could be applied. I went again to the bibliography to see how was the field going, and I found this interesting publication that was collecting other publications and with very interesting information, like the data set size, the input variable that they were using, also the architectures that they were using. And for me, it was really, really useful to have this information. For that reason, I am sharing that with you, because maybe will be also useful to you in case that you want to apply something similar. For sure, based on the sensors that I had, I could apply some specific methodologies. But then I decided just go for the first one. That is the one that was this publication focus on, and use 1D CNN. Just as a recap, for my data set, what I was using, I monitor different variables like the CO2, the ppm, as I mentioned, the humidity level, the temperature in Celsius degrees, the particles, and also I collect the activity level because these sensors were in the area that I was working. This means that this room, it's not 24 hours occupied, or could be more or less, depends, right? If I am working, overworking, not side projects, and these kind of things also had an effect in the system. Also, add some other information in case that you are into, if you have interest. Uh, but let's continue because I want also to share more information with you. Um, Something that I love from this kind of projects is the way that you can do this windowing Windows system, how you sample the data, right? In this case, what I'm indicating here in this schema is how create these windows. The N, that is the number of days or hours or months, depends of the kind of system you need. And it's a mobile window. This means that what we are gonna do is go through the time and iterate in that way. And also what we are gonna do is like, okay, this is the time that I decide to use. What is the prediction in this time? Okay, then again and again and again and again. Of course, this end gonna be different, depends of a lot of factors. Gonna be different, it depends of your city, depends of the features that you are using, depends of a lot of things. It will not be probably the same for everyone or all the cases, as always in data science. About the architecture, I'm not gonna go really deep on that because maybe not everyone is interested on that, and also it's really specific. And but if you want to discuss later or at some point, it's okay, we can do it. If not, it's also okay. In this case, I use this one-dimensional convolutional neural network. That is the same that was using the publication that I mentioned before. If you're familiar with the time series in using deep learning, maybe you're curious to know why no LSTM and why this. Of course, also LSTM could be also an option. The thing this is lighter, and my idea was to have a lighter system to have more flexibility and, well, other kind of characteristics that I was looking for. Also, I thought that it was really well. I was really convinced for the publication that I found it, and I decided to give a try to that. And here we have a really specific part that it's the framework I was using. In this case, is TensorFlow and TensorFlow Keras. In here, I also add some specific information in case that you are curious. I'm not gonna go also really deep on that because if not, we are gonna not have time to finish. But I love to see this kind of information in this kind of presentation of data science. For that reason, I decided also add it just to give you information. But then here, maybe the key information is in here we have the convolution 1D that I mentioned before. And here we are analyzing and extracting the features. In this time, we are considered this window size and also these features. And then we are going to have an output to predict the CO2 values. Well, we had different metric and results. In this case, it was the root mean square error, but I decided to use as a performance metric. I also work a bit with some hyperparameters, but as it is a data science project, It needs to be a iterative project and thing, and always gonna need some kind of improvement, of course. And in this case of windowing, what I was doing is pick some random days to check how was the prediction. And I can tell you that depends of the windows performs better than others, because depends if there was something happening. And well, it's sometimes it's tricky. But in general, you're gonna see that looks quite okay. And here I'm sharing with you just three plots that illustrate a bit as example for sure. 24 hours. I was using 24 hours to predict 1 hour. And what I have is the in green we have the label, and in orange we have the prediction. And as you can see, it's not super precise, but at some points are quite okay. But at some points there are some shift and drift, and well, there is some improvements that needs to be done at some specific times. But and overall, it was quite positive, the result. In here, I'm gonna show you the last element, that is how was displayed the data in the Raspberry Pi. In that system, I built a Flask application to illustrate that, and then how everything looks together, right? Because it's like, wow, so much information, but I want to see how it looks like. This is how it looks like. I also have it here in case that of course now it's disconnected because I wanted to show you, but this is how it looks like. It's quite small, and I have this as a decorative thing at home. And here was a picture of my sister. I removed it for add some sensors. Don't tell her now that she's not listening to us, but yes, I have it as a decorative element at home. And then here is how it looks like. On the left we have the CO2, on the bottom we have the temperature and the humidity, on the right side we have the prediction and also the data. And as you can see, we have different colors also to illustrate or show how was kind of changing. As a last thing, this is a really small demo showing how was changing depends on the prediction. And there are some work in progress. Just to let you know, I am improving the system. I am also changing to try to have TensorFlow Lite for to have machine learning in the microcontroller directly, and also include the particles information in our model, because was not included at the end because I had some issues and I decided that was affecting too much to the prediction. I had to remove it. And with that, I just want to motivate you to create your own system and to improve your home. And of course, if you want to be in touch, I will be more than happy. And with that, I'm going to finish. Thank you so much.
Thank you for the great presentation. There's a couple of questions, but we don't have time anymore. If it's okay with you, the people can reach out to you in the chat. I'll leave the session open so that you can answer. Yeah. And well, thank you very much. Any Twitter or a way for people to contact you better?
Yeah, absolutely. Yeah, it was in the last slide. If not, I can also share it later on in the chat or yeah. In here, okay. Yes, in here we have all the sites.
All right. Well,
thank you so much.
Thank you very much, and enjoy the rest of the conference.
Thank you so much.